Okay, maybe we can continue with our exploration of using pandas, and we'll continue working with the same data file now, but we're going to get a little bit more into what we can do with data sets in pandas in the second part of today's lesson. And then, of course, time permitting, we'll go through a little bit about this week's exercise. So now I've opened up this data manipulation notebook. So the other notebook that was part of today's lesson materials. And as you can see here, in the first cell, we have our typical import pandas as PD. And we're going to read in the same data file that we had before, but we can go ahead and do this slightly differently now that we'll specify this file path variable fp. So this is a very typical way to do things when reading in data files in Python, is that you set a variable that defines the name of the file you want to read, because then you can easily just change that value without having to change anything else in your notebook if you read the data file in several places, for example. So our data file here is data/kumpula, and actually one handy thing in pandas is you can start typing the file name and hit the tab key, and it will show you what it thinks is the best way to autocomplete this, which you can then click on if you don't want to type in the entire file name. So that's kind of a quick trick to save you from having to type in these long file names, but it's data/kumpula-summer 2024, same file we were just working with. And just like we did when we read this before, we'll read it in as a variable called data using the pandas read CSV function. And we'll give, instead of the file name here, we'll just give fp, the variable name that contains the name of our file. And then, like we did before, give our skip rows equals 8 parameter, so that we skip over the metadata at the start of the file. This is basically the same thing we did before, so just getting us back to the state we were in last time, because we're in a new notebook and we have to read this file information a second time as a result. So run that cell, and you should very quickly see that if everything went well, our file appears to have been read, which we can check using the head function, data.head. And maybe I'll just make this a little bit bigger. And looks like everything is okay. We can see our column here with our dates looks to be formatted properly. So we have the 4 characters for the year, 2 for the month, and 2 for the day. And then our data that we had previously is here, max, min, temp1, and temp2. So that's good. And we can start out by showing you how to add a column to your data frame with a new value in it. So if we wanted to add a place to store something like the difference in temperature between the max and min, we could take our data frame and add here a column called diff. And for instance, set diff equal to 0.0. We'll just initialize it with some value like a bunch of zeros. And if we do that, and then we do data.head afterwards, we can see what has changed in our data frame compared to just a moment ago. And when you run this, you should see that now we have an extra column. You can kind of see the 2 data frames in comparison to one another here. So we've added a new column called diff, and it's full of values of 0.0. No surprise there. So depending on what you're doing and how you're working with your data set, sometimes it's useful to initialize values to just fill in a column with a sort of default value that if you don't put something else there, it will keep. But of course, we don't need to do this, and it doesn't need to be zeros. I mean, we could fill this in with some other text string. Essentially, any value for a variable here could go in to indicate what kind of data you'd like to initialize things with. But we could check our new column here by seeing what its data type is. So if we look at data.diff and then check the d types attribute. If you run this, you can see that the data type for our new column is float64. So this is a floating point number with 64-bit precision, kind of what you would expect for a decimal value that you put into a pandas data frame, because by default it will use 64-bit precision, and of course 0.0 is a decimal value, so it's of type float. So nothing really super surprising there, and in fact our diff column is kind of boring and not that useful at this moment. So let's instead put something there that's perhaps a bit more interesting. And we could redefine or overwrite the values in our data diff column. And instead of storing 0.0, let's make it the difference in the temperature between the max and the min for our data that we have. So we can say here, data max minus data min is what we will store as diff. This maybe makes a little bit more sense because now it's the difference in temperature between the maximum value for that day and the minimum value for that day. And again, like we did before, we can just do data.head underneath this so that we can see the change right away. So we don't expect to see an additional column. We already have a column called diff, but instead we should see the values in diff have changed. And now, sure enough, when you look at the values that are stored in diff, you can see values like this. They're all positive numbers, as you would expect. When you subtract maximum from minimum, you should get a positive number or 0. And so we see a bunch of positive numbers here. And just kind of quickly eyeballing this, we can see that 25.7 minus 15.2 is in fact 10.5. Looks like this is working correctly. So that's good. This diff column did not need to exist previously in order to do a calculation like this. We showed an example of how to initialize things, but you could do this without making the diff column first as well. So you can kind of create on the fly a new column in a data frame, which is a handy thing to maybe know about. We could also calculate another value here for another column. We could make an estimate of what the average temperature is for the day. We have only 2 temperature values that are measured at different times of day, and then we have a max and a min. So we could estimate this average temperature in a couple different ways, but let's just say if we wanted to make a new column called data temp, we could call it av temp or something instead, but whatever, temp is fine. And we just take the average of the temperature at 10 o'clock and the temperature at 2 p.m., right? So that's what's in temp 1 and temp 2 in our data frame. It's probably not a great estimate of what the average temperature is for the day because frankly it's skewed towards the warmer parts of the day, but for our purposes this works just fine. And we can do this by saying, for instance, temp 1 plus data for column temp 2. And let's go ahead and wrap this in parentheses because we want to divide it by 2. So we're averaging. Add 2 values together, divide by the number of values, and you get the average. And again, let's do data.head after this. So we can see what we get when we do this average of the value in temp 1 and temp 2 and divide those by 2 to get our kind of rough estimate of the daily average temperature, which we know is not very precise, but that's fine. So you can see here that we get average values that look like this. 22.8 is the average for our June 3rd. Which if you take 22.5 and 23.1 and add them together, that looks correct to me. So this, again, looks to be working correctly. And in this case, you can see that we've created this temp column on the fly, so we didn't create it beforehand. Which brings us here to the first task for you folks, and that is to calculate our temperatures in kelvins using the Celsius values and storing the result in a new column called temp Kelvin. So you can use the temp values in Celsius to do this. the ones that are in the new column that we just created, though frankly it doesn't really matter which temperature you want to choose. And just noting that our equation or conversion factor from temperatures in Celsius to temperatures in Kelvin is just it's the temperature in Celsius plus 273.15. So take a moment here in the cell beneath the question to calculate the temperature in Kelvin using one of the temperature columns. It can be sort of yours free choice to select which one you want to use. As we did before, if we want to make a new column, we basically give a new column name here in quotation marks. For instance, in this case, temp Kelvin. And all we want to do in our conversion here is just take one of our data frame columns that exists with Celsius temperatures, such as temp, and then add to those temperatures in Celsius 273.15 degrees. And like we did before, we can do data.head to see the first 5 rows of our data frame that results from this. So nothing really different from what we did before. We're just creating a new variable called temp Kelvin, or new column in our data frame called temp Kelvin. That's our value from an existing column plus some scalar 273.15. And you can see if you run that cell that you get these following temperatures. And looking at the values we have in temp, you can see that they look more or less correct in what the output is that we get here. So now we know how to add columns to a data frame in a relatively simple case, calculating something from another column and using that to create a new column, for example. What we don't know yet is how to pick out values from our data frame to do things with individual rows of values, columns of values, whatever it might be. And that's what we're going to cover next. It's how to select and update parts of our data frame. And our simplest case is to work with something that is similar to how we would do selection of ranges of values in a Python list. So we could, for instance, start with our first selection, which we'll just call, logically enough, a new data frame called selection, in which we can take data from rows 0 to 5 in our data frame using the kind of index selection and index ranging, kind of like the range function we used in Python for lists earlier. And let's do that. And then we can just, because we only have 5 rows, let's just print out the entire contents of selection. Selection.head would give us exactly the same output. So what you can notice here is we get 5 rows of data. And the index column over here you can see goes from 0 to 4. This is like how we did with the range function, where when you said range 5, it gave you the values 0, 1, 2, 3, 4, because it goes up to, but does not include this last index value in the selection here. So that gives us the first 5 rows of a data frame. And it's quite similar to how you would do the same thing with a Python list. So that's perhaps at least somewhat familiar. And if you change the numbers that are used here, you could, for instance, start from a different row. So we could, for example, start at row 2 and go up to row 10 or whatever. And you would get, of course, a different selection. In this case, starting at index 2 and going up to index 9, because the index 10 is excluded from the selection by the way Python selection of ranges of values works. So this is what's broadly called slicing, or it's basically slicing, whether it's a Python list or an array or data frame. And it's a way of extracting a piece out of a data frame. The thing is, in pandas, we don't normally do things this way. Instead, there is a built-in, it's sort of like a function in pandas called called loc. It's actually an indexer that allows you to select things based on the index values, because in pandas, one of the things that's flexible about it is that the index value doesn't need to be a number, so it doesn't have to be 0, 1, 2, 3, 4, but instead could be a date, or it could be some other value. And that means that the selection with a range of things like 0:5 doesn't always make logical sense. So instead, there is this loc indexer that's used in pandas. So let's make another selection. This time, we're going to do data.loc. And the reason I said that this is like a function is that it does work in some ways similar to a function. However, it has square brackets. And that's because it's this kind of indexing thing, not a function. Because it's selecting a range of things, it wraps in square brackets instead of parentheses. So pay attention to that. It's, I think, kind of an unfortunate and confusing thing that it looks like a function, but it uses square brackets. And we could, for instance, do the same thing we did before, 0:5, but let's add in this time that we only want to do this for the column temp. So this is one thing we couldn't do before. We couldn't select a single column to get the rows out of here. So this is already a good use of this loc indexer, because we can get the rows we want and a specific column. And again, if we just look at our selection after doing this command, you can run this, and you can see here that we get out now 6 temperatures. So something is different here. When you use the loc indexing, it goes up to and includes the last value in the range that you give here. So be aware, this is, again, something, there's a lot of things that make good sense in Python. This is one of them where I'm like, why did they do it this way? But when you start using things other than values like 0 and 5 for the index, when you start using dates, it does become more logical, because you don't have equally spaced things. If you want to make sure that you get your selection to include the values you want, this kind of including the last thing in the index selection does make a little bit more sense then. And because we have only one column from our data frame that we've chosen, we just get this array of values that comes out here. But you can see the index goes from 0 to 5 in this case. So it's a little bit different than what we saw before. And you can see here that the basic formatting of using .loc is that you have the first included label, the last included label, and then whatever columns you want. That's the general format. So if we wanted, we could select multiple columns from our data frame and do this same thing. So let's just copy what we have here, because we don't need to type it in twice. And let's paste it down here. Let's take the same rows, but let's get 2 columns. Let's get temp and temp Kelvin. And the way we can do that is we put inside a Python list the headings or the names of the columns that we want. So now we have temp and temp Kelvin inside a Python list with a comma separating them. And running this, no surprise, we get back temp and temp Kelvin. We still have our index going from 0 and including 5. And we have a new data frame that is a selection of the values out of an existing data frame we had been working with earlier. I think this is noted maybe elsewhere in the lesson, but you'll notice here that the format looks a little bit different when we made our selection from a single column. This is a pandas series, so it is a slightly different data structure than a pandas data frame. When you select a single column or a single row out of a data frame, it is a pandas series. It works more or less similarly to data frames, but because it's a one-dimensional thing, it doesn't have some of the methods that you can use on data frames. But it's very efficient to work with a series because it's very close to a NumPy array, which is an efficient way of storing numerical data in Python. Okay, another question for you. Your task now is to calculate the mean temperature in Celsius for the last 7 days of August 2024. And you can do this using the row index values. So this should be the values that are, for instance, here. You want to get the last 7 days of August and calculate the average temperature. And let's say for this, you can take the average temperature from the temp column. Doing this task requires a couple things. First off, we need to know which index values we want. And the easiest way, because we know our data set goes up until the end of August 2024, is to start out by doing something like data.tail. And let's give ourselves, for instance, 7 values, because that would give us output here for the last 7 days of August, and you can count them here. I guess in this case, we actually have 8 values, don't we? No, there's 7. And the reason to do this is that you can see the index range that we want. So it goes from 85 up to 91. So in order to make our selection, then we can basically go data.loc. And as we just saw, we give our range of index values we want, so 85 to 91. We want to use the column called temp in this case. And to calculate the average, we can just go ahead and add this .mean function to the end of what would be selected from this selection, because this is a pandas series that will be generated when we run this .loc command, and .mean is the way in which you can calculate the average of a series of values in pandas. So like that, we select our 7 days from the temp column, calculate the mean, and we get something like 19.671, which is hopefully what you ended up with. It can be a little bit confusing maybe when you start chaining these things together. So you could, for instance, store this as selection and then do selection.mean. That's totally fine. So you could, for instance, say selection equals data.loc and then do selection.mean. If it's clearer to you to do it that way, that's fine. The point here is that you don't necessarily need to store that as a separate variable, but you could just add .mean to the end of it and get the same output. Okay, so let's go on to some other ways in which we can select things, because we have a bit of content to cover in this lesson. So one thing we could do is select a single row out of a data frame, which we could do, let's call this row, and say row equals data.loc, and just give a number. This will give us the value at row number that has the index number 4. And I guess I should type row here underneath it so we can see what our output looks like. But this gives us a pandas series that contains all the values at index 4. So we can see our year, month, and day, max, min, temp 1, temp 2, etc. All of the values we would have for each column for that single row. So this will return a pandas series. Just like if you select a single column, you get a pandas series. And if we wanted to, we could get a single value from that by doing, for instance, row, let's take temp. And we just get a number out of this. This is the floating point number, but it's just 21.75, which is the value we have here for temp in our row number 4. So there are occasions when you want to just access a single value in a data frame. They don't happen that often, but if you want to do that, there is a special indexer called @ that we can use. So we could, for instance, do selection.at, and then we could give an index like 0, which would be the value at index 0, and then a column called temp. It's going to be unhappy because I think I deleted our selection earlier when I did this. So let's go back and undo our things and make our selection again here. So just go back up to above question 3.5 if you followed my example, because we, in making our selection earlier, deleted some things that we need here. But then with this, we can do selection.at to get the value that is at index 0, so the first row, and in the temp column directly, so 23.7. And if we just scroll back up for a second here, we can see that 23.7 is the first row and the value from the column called temp. So that's how you can do that. It's not necessary to do this. If you have some workflow where you really need to access a lot of individual values for some reason in a data frame, .at is faster than .loc because it's designed to get a single value. It's kind of optimized for that type of operation. But you can also do exactly the same thing using .loc. So you could say, for instance, selection.loc and then give 0 and temp and get the same output. This is slightly slower because .loc is designed to be able to access ranges of values. So in some cases, performance is really critical. You could use .at, but generally speaking, it's better just to use .loc because it's the one that you use all the time for other things. So there's no reason to bring in .at unless you have a really specific case. On the book webpage and also here in the notebook, there's some stuff about using index positions to select values. It uses an indexer called .iloc. We won't go through that because it's not something that we use elsewhere in the course, but it's here for the sake of completeness. If you're interested, you can go through and see that stuff in the notebook, but we'll skip over it for right now. But there's other ways we can make selections, and one of them, for instance, would be to select certain rows that we want to use using criteria. So we can use this .isin function of in pandas that will allow us to select values that are within our data frame in a certain column. So we have here the selection criteria, and you can see that there's 4 different dates here. So 1st of June, 8th of July, and the 9th of August, just kind of randomly selected. And if we take our data set and do .loc, we could say, let's look inside of our year mode column, and then add here .isin, and then our selection criteria. So this will give us the values from .loc, where we meet this condition that the year mode value is inside or contained within our selection criteria. This is something I don't use that often, but it's maybe useful just to see, because there could be some cases where you want to give a list of, for instance, dates or other values to just get those specific rows and columns from your data frame. And if you run this, you'll see that what this basically does for us is just give us these rows for our different dates that we have. So 1st of June, 8th of July, and 9th of August, and then all of the columns that go along with that. What's perhaps a bit more common would be to make a conditional selection. So here we're going to use a conditional statement to allow us to choose values from our data frame. So when working with temperature data, we could say, for instance, if we look at the data, where our max temperature for the day is greater than 25 degrees. So this would be our kind of hot days by Northern European standards. And when you run this, what you get back is an array of Boolean values. So these are true or false values that tell us At index 0, it's true that the max temperature was greater than 25. At index 1, it's false. At index 2, it's true. And if we went back up and looked at our, I don't know where the last time we saw our data was, and we don't have the max column, whatever, you'll have to trust me on it for the moment. But this allows us to then use some condition to pick out values. Like if we want to find days when it's below freezing or whatever, we can easily do that here. We could, for instance, make a new data frame called hot temps, where we use the same condition we just had a moment ago. So data.loc, and let's make it that our, let's do it like this, data max, so the maximum temperature for the day, is greater than or equal to, let's do it like that this time, 25 degrees. So we'll consider 25 degrees to be hot as well, and then we could look at, for instance, hot temps to see what we get from this selection. So what we had a moment ago was just this piece, or I mean it was greater than 25, not greater than or equal to. But this gives us an array of true or false values as the output. So when we put this into the .loc indexer, anytime that thing comes back as true, it will give us that row from the data frame. So what we can see here now when we run this is that hot temps comes back, and you can see now in the max column that we always have values greater than 25 degrees or greater than or equal to 25 degrees. And you can see the index values that are listed here showing up, that we have selected things out from our data frame. So it's maintained this reference to the original index that was given there. And as we saw before, when we did this condition by itself, data max is greater than 25. We saw that this should be true for row with the index of 0 and the index of 2. And sure enough, index 0 and index 2 are here within our selection, as we would expect. So this is a nice thing because it allows us to pick out and identify values, not based on index, but based on a condition about the data itself. So that's quite handy to be able to do. And we could get a little bit more, I don't know, fancy with this, sophisticated, whatever you want to call it. Maybe complex is the right word. Let's make a selection of warm temperatures. And for our warm temp, let's do data.loc, because we'll still use our .loc indexer. But now let's give two conditions. Let's say the temperature has to be greater than or equal to 20 degrees. We'll call that warm. And it has to be from the second half of our data set. So we'll say from July 15th onwards. The way we'll do this is we'll put our first condition in parentheses here. So we can say data, and we'll say the average temperature for the day instead of the max temperature for the day. Has to be greater than or equal, let's just go greater than 20 degrees. That's our one condition. Now what we haven't seen before is this ampersand operator. But you remember when we had conditional statements where there was one statement and then we had the word and in another statement, that's how you made two conditions have to be met. The same thing can be used in logically. This and symbol works the same way as and would with a single conditional statement. However, it's a bitwise and, which means it will check rows of data instead of a single value. So we have our condition that temperature has to be greater than 20 degrees, and we have now another condition that our year moda, so year month day column, has to be greater than or equal to 2024-07-15. So this is 24 July 15th. Those are our two conditions. And we can then check warm temps after that. Yeah, question? Yeah, we can. Let's run this first, and then I'll show you what happens if you. I mean, of course, you can test it on your own, but yeah, you can't use the word "and" here because what it is going to complain about is it's trying to compare arrays of values, and it doesn't know whether you. It can be somewhat ambiguous whether you should have a single case that meets this condition, or it should be like for every row that meets this condition. So if we put in the word "and" here. Yeah, it basically tells us exactly this, that it's not clear, like, what do you want to use? Are you trying to say that, like, this should be met if any row meets this condition, or all rows, or is it that you want to go kind of row by row and check, which is what this ampersand operator will do, is it checks each row and says, in this row, is the temperature greater than 20 and the date greater than our minimum date? So when you run this, you should see output that looks like this. And let's check to see, does it look like it worked? First off, year, month, and day greater than July 15th. That looks to be the case. That's our first date in our selection here is the 15th of July. So that's good. The other thing we can check, is the value for temp always greater than 20 degrees? And again, looking through this, yes, it looks like we also have successfully selected the values that we wanted to be temperatures greater than 20 degrees. So that's good. And you'll notice again that we have the index here still maintaining the reference to the earlier original source data. So we start here with index 44. If you want, you can also tell when making these kind of selections that you don't want to maintain the old reference to the index from the source data frame, and you can do that using a method called reset index. So we could, for instance, say warm underscore temps equals warm temps dot reset index, and then we can say drop equals true. So the drop equals true thing here is because otherwise, if you just do dot reset index, it will make a new column that contains the old index values. So it will set the index to start at 0 and go up to whatever, but it will also have an additional column that then stores what the original index value was. And in this case, we just don't need that. So if we do this, and then we run warm temps, what you can see is it basically done what you would expect. It reset the index to start at 0, and it just goes up by 1 until we get to row, I guess, 26. I don't know why I said it goes to row 47. That's not right. So that allowed us to make our selection and then set the index back. Depends on what you're doing. Sometimes you want to maintain that reference to the original data. Sometimes you don't. So there's one other thing. I'm not going to go through it right now because we're starting to run low on time. But you can see if you go, for instance, to the Python gisbook.org, the link that would go from the lesson materials for this lesson, you'll see in here in the section about selecting and updating data, there is an example of a warning message you can get sometimes. There's our conditional selections. And somewhere down here, did I scroll right past it? It should be here someplace. Yeah, here. So this is an example of, there are instances where you make a selection and if you don't reset the index or do what's suggested here, which is to make a copy of the data when creating a new data frame, it will maintain a reference to the original source data frame, which means you can modify the values from the original source. And when doing this, you'll get a warning message if you have a reference to an old data frame, that pandas will warn you that there's potential danger for interacting with your data in this way. So as a result, it's suggested to make a copy of the data frame when creating selection from it. So there's something on the course page you can find about how to do that. But for us, we can skip past that for right now and go to question 3.6, which is where you have an opportunity to make this selection for the last 7 days of August again. But this time, you can do it using a condition that you apply to the year mode column. So instead of using the index reference, this time do the same thing where you calculate the mean temperature in, for instance, the temp column for the last 7 days of August, but this time use a condition for the year mode column. And we'll continue in a minute or two after you have made an attempt at that. So perhaps I'll start going through this example and you can just avert your eyes if you're still working. But the basic idea here was to do a selection the same way that we have earlier using data.loc. But we wanted to apply a condition here, and our condition this time is that our value in the year mode column should be giving us the last 7 days of the month of August. So that means it should be greater than or equal to 2024-08-25 to give us the last 7 days of August, which if we just run this by itself, you can just confirm 1, 2, 3, 4, 5, 6, 7 days. Yeah, that looks to be okay with that selection. And just like we did before, we can add .mean to the end of this to then calculate the average from that column. Now I didn't select, as I probably should have here, the temp column. But if I select only the temp column and then use this .loc to give us the dates that we want, we get 19.671, which is the same average that we had gotten earlier when making the selection using the row index values. Any questions at this point? Okay. We can skip the next stuff too, this view versus a copy. This is basically going back to the same issue that I mentioned a moment ago about sometimes getting this warning message when you're working with a view, which is a selection out of a data frame where it just has a reference to the data from the original data frame, versus a copy, which is an actual separate copy stored elsewhere in memory from the original data frame. This just gives you a little bit more information about working with that common issue that occurs when using pandas and making selections. But something that's more important for us to work with here is missing data. So right now, if you take a look at our warm temps, for example, some of you may have already noticed when we look in warm temps that there are these nan things in here, and they're in a variety of places. Nan in this case stands for not a number, which indicates missing data from when we read in our data file. So for instance here, we read in our data file, and on the 23rd of July, the maximum temperature was missing from our data file. And same thing for the 24th. And there's other places where it's missing for the min temperature. So that's what we're going to deal with next. An easy way to check, for instance, one of the columns from our data frame to see does it have any missing data is we could, for instance, do warm temps and then take one of the columns like min and check the attribute is nan, or has nans, sorry, has nans. So has not a number values. And when you run this, it comes back saying true. It checks this column for the minimum temperatures right here. Sure enough, we can see that there are multiple missing values, NANs, that are here. And so with this Pandas tells us, yep, there are NaN values there. So when you want to check a column quickly, that's one way in which you can do it to find out if there's any missing data. Now we know that we have missing data, so what do we do? Well, one possibility is we could select some of the columns where we want to remove rows that have missing data and simply remove them. So we could say, for instance, here that we have columns to check as a new variable. We'll put in a single column here called min, which makes that kind of easy, but you could list multiple columns there just as well. And we could make a new data frame called warm temps clean that equals our warm temps, where we apply a function called drop NA. And we give our drop NA a parameter called subset equals calls to check. So what's going on here? Well, we've specified the name of a column, min, and we're using this drop NA function in pandas, which will remove a row if it contains a missing data value. And the subset we're going to check is it's only going to remove rows where the min column contains missing data. And if we check our warm temps clean, after running this, what you'll see is that now the min column does not have any not a number values in it. You can see there's 26 values here based on the index. And oddly, I don't see the output of the number of rows at the bottom of the, beneath the data frame here. But you can see, for instance, that index 24 has been removed. Are there any other ones that are missing? So some of the others are also dropped here. If we went back up to our original data, you could see that 9, 10, and 11 all had NaN values, and that 9, 10, and 11 are missing here from our new data frame. So we've effectively cleaned our data based on the rows where min is not a number. There's still some other NaNs in here though. So that could be a problem. Maybe we're okay to work with that. Maybe we only cared about the minimum temperatures. But another approach here is to say, make a warm temps clean, where we simply drop any row that contains not a number from warm temps. And we can just do this as warm temps.drop NA without specifying a subset. So this will give us any row where it finds an NA value or not a number value, and it will just be dropped from our data set completely. And if we check out warm temps clean after running this, you should see now that there are no columns where there's not a number values. And also, if we check back to what we had before in our earlier output, we could see, for instance, here that in the columns labeled 5 and 6, that we had not a number values for our max, for example, and that columns 5 and 6 are now gone from our data frame. So this is a kind of quick and easy way to drop a whole bunch of values from your data frame. However, it's not necessarily a good idea, because there can be some cases where you have a column that has a lot of missing data. We, in this case, have only read in temperature values, but another common thing you could read in would be like wind speed and maximum gust of the wind speed. And oftentimes you'll have either recordings at different times or missing wind gusts. If the wind speed is low, it doesn't separately record a gust speed, which means you can have huge numbers of rows where there's missing data for the wind or some attribute of the wind. And if you drop based on that, you'll delete most of your temperature data as well. So it's kind of a better practice in general to use this subset parameter to always tell which columns you want to drop values from, just to be safe. So again, depending on the data file, and as you're working with it, you may figure out there are, you do or do not need to worry about this, but in some cases, dropping NA without a subset can be a bit dangerous, and you just end up deleting most of your data from your data frame. An alternative to dropping values using drop NA is to use the fill NA function. So those of you who have worked with GIS software before might remember that oftentimes there's some value given to represent missing data where you don't want to remove it from a data set, but simply just not display something if there's missing data. So like if you have a raster, let's say a digital elevation model where there's missing elevations, rather than deleting that entire row or column of values from your digital elevation model, you simply specify a number so that the software recognizes, okay, I don't have an elevation here, so I simply won't show a point for that place where the data is missing. So for that, you could use, for instance, warm temps .fill NA with a number, for instance, -9999, which at least back ages ago when I did stuff with GIS software, that was a common value to use for missing data. It's been a minute since I've used anything like that, so I don't know whether that's still true. But the point is that you could fill in the values where you're missing data with this -9999 instead of having a no data value. This is very much kind of application specific. So there are cases when you want to do this, and there are cases when this is a terrible idea. The data set we're working with would qualify in the latter case. I would say it's a terrible idea to fill in values here, because now if you want to calculate the average temperature or the mean or the max or whatever, median, you're going to have this -99 in there, or -9999, skewing all the values heavily. So if you were to calculate the average temperature from the max and min for the 23rd of July, obviously you're going to get a value of something like -4,900 and something, which is not a meaningful temperature. If you have latitude and longitude values and you're filling in missing elevations, maybe this makes sense because the software you're using might recognize that and simply not display a pixel where this missing data is. So you have to pay attention to whether you want to drop values or fill them, but the point is with pandas you can do either one. All right, let's see what we've got still here. Yeah, of course we can do this for a single column as well. You can find how to do that on the course page. I won't demonstrate that example here, but it's very similar to how other things work. So that's kind of how we can handle no data values, basically getting rid of the columns and rows or whatever that contain them, or filling in missing values. But another thing we might need to deal with that we haven't dealt with yet is type conversions. So way back in lesson number 2, we dealt with how to convert things like character strings, or I think it was numbers into character strings, to be able to print something to the screen, for example. And of course, you can do type conversions for data in a pandas series as well. And so we could take, for instance, our temperature values. Let's just have a quick look first at what we have in our data temp column. And let's just do .head to get only the top 5 values. So we can see here we have temperatures, just like you would expect as a floating point value, right? They have a decimal place, and we could convert those, no problem, to be instead an integer value by doing data temp .as type. So we're not going to use int to do this, but we're going to do .as type, which will convert our data to be as type integer, and let's just do .head of that output, so we get just the first 5 rows from that conversion. So you can see both from the fact that we had a float 64 data type before and an int 64 data type now, and the fact there's no decimals after the numbers, that this type conversion has worked successfully. And that's true. The type conversion has worked successfully. However, most likely it has not done what you wanted in doing this type conversion, because what happens when you take a value from a floating point number and convert it to an integer without telling it anything else is it truncates. It just says, okay, anything after the decimal place is just gone. So 23.7, which most probably you would like to round to 24, just gets represented as 23. The 0.7 is gone. It effectively rounds everything down to the nearest whole number. That's maybe useful in some cases. I think I had an example of doing something like this the other day, where I was trying to just kind of identify values that were separated by like hundreds, and I just wanted to get the first digit. I didn't care if it was 101 or 199, I just wanted the first digit. And in that case, I just truncated everything, and it worked fine. But most of the time, you want to round your numbers. So the way we can do that is using this round function, and we can simply string these things together. So let's take data for our temp column. Let's first do .round to have zero decimal places. So we'll round to the nearest whole number. Then we'll convert it to as type int. And then we can do .head to get the last, or just the first 5 values rather. So we're kind of chaining these things together. The big step here is we're doing this round operation first and then converting to an integer. If you do that in the opposite order, you'll get different results. So I guess we could show that one, but let's run this first. Oops. So now you can see that our output is 24, 22, 23, 22, 22. And let's just check. 24, yes, we properly rounded up to that. 22, we rounded down to that. 23, rounded up. 21.95 got rounded up, and 21.75 got rounded up. So this looks like it worked as we would expect. Now, just for the sake of demonstration, the order of these things matters. It's kind of like a filter in a sense. So if instead we did .asType int and then .round, I don't even know if it's going to let us do that because it may complain that you're not allowed to round an integer value. No, it doesn't complain. But it also doesn't work. Because what happens here is it first converts to type integer, then it rounds to 0 decimal places. So we have the same truncation problem we had before. We basically need to do the rounding operation first. So when doing this, that needs to be the first thing you apply, then convert to an integer. And in this case, we just did .head to get the first 5 values. So just a small word of warning that the order of these things does make a difference. All right, I think our last topic for today is about sorting data. Again, a very typical thing you want to do. If you think about this, we're working with tabular data, right? It's basically spreadsheets in a data file. And I'm guessing if you've worked with Excel in the past, you've had some cases where you want to sort things. Sort by date, sort by first name, sort by whatever. Super common thing to do with tabular data. And of course, we can do this with pandas as well. So we could sort our data frame in ascending order. Let's say by ascending order of the temp column by simply doing data.sort underscore values. And then we give a parameter here called by, which is going to tell us which column to use. So just like Excel, you would normally select the column you want and click the sort button, and it would sort based on that column, and everything else, the other kind of rows would also get kind of stick with each other, and things would get sorted properly. So if we do data.sort values by temp, and this is ascending, you can see now that our lowest temperature day was from June 9th, and all the temperatures increase up to our warmest temperature that we recorded on the 28th of June. No surprises, right? So we sorted by temperature, and sure enough, things go in ascending order by temperature. You want to do the same thing in descending order. We'll just copy paste what we had from above and add one more parameter here, and we'll say ascending equals false. Okay? If you don't want it in ascending order, it means you want it in descending order, which is what happens when you apply ascending equals false. And now you can see things sorted with the warmest temperature at the top and the coldest temperature at the bottom. So I think this is kind of fairly intuitive how sorting works in pandas. Now there's another example that's given here in our lesson notebook of a slightly more complicated situation. So let's imagine that you want to sort by multiple columns, which is also something you may do, for instance, when working with data in Excel. In this case, let's imagine that what we want to do is we want to first sort by which day of the week it is, and then for each day of the week, we want to sort by temperature in, I guess, descending order. So what we would end up with in our output is we would have, for instance, all of the Fridays first, and then we could see in order which was the warmest Friday in our data set and what was the second warmest, etc., down to the coldest Friday in our data set. This is kind of a silly example, but it's just to demonstrate the way that this works. The first thing we have to do, though, is we have to add the day to our data frame. So that's what the two lines that are here will do. This basically just is a list. The first day in our data set, June 1st, was a Saturday. So it has Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday here, 7 days. And altogether we have 92 days, which is 13 weeks plus 1 day. So our day list will be 13 times this list, which will just repeat it 13 times, plus 1 extra day, which would be the first day of our list. So there's 1 extra Saturday given here. We can add those to our data frame by simply saying data weekday equals day underscore list, because our day list is basically what we generated here. So we're adding a new column. This time it's a Python list, and we're going to fill in our day of the week, and then we'll just take a look at what's in data after doing that. So you can see, for instance, that the 1st of June is a Saturday, then it's Sunday, Monday, Tuesday, Wednesday, and so on down to the last day of August, which was a Saturday as we expected. And it looks like the day of the week has properly been added here. There's a lot of different ways to solve this problem. If we wanted to do things differently, there are plenty of options for how to get what day of the week it is in a pandas data frame. But what we did is we basically just manually assigned those values. But now that we know for each row what day of the week it is, we can do something like sort by which weekday it is, and then apply a second condition to allow us to sort by the temperature, average temperature for that day. So we could say, for instance, data.sort values like we did before. And now we say by equals, and we're going to give 2 things in a Python list. So we can say weekday. So we'll first sort by which day of the week it is, and then we'll sort by the temperature of that day. And when we do this, we're also going to give the ascending parameter. And in this case, we'll sort in ascending order for which day of the week it is, which means when it sorts, it's going to go alphabetically. So Friday would be first. It doesn't know that the first day of the week is Monday or Sunday, depending on what your reference point is. But it's going to sort alphabetically so that Friday's first, but then it's going to sort in descending order within all of the Fridays, meaning that we'll see the temperature go from the hottest Friday down to the coldest Friday when doing this sort. And so if you run this case, I guess I need to have an extra closed parentheses here. You'll now see that we've sorted things alphabetically. F would be the first letter for, we have Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. And so F would be the first letter you'd encounter in the alphabet. W would be the last one, so Friday at the top, Wednesday at the bottom. And within all the Fridays that we have, we can now see that temp is sorted such that the hottest Friday is first, and then the temperatures on the Fridays are descending after that. So we're just showing that you can sort by multiple columns here when doing this kind of sort operation, which can be handy in some cases. Finally, there's something about table joins at the end of this lesson. This is not relevant for us this week, and I have not updated this part of the lesson notebook at all. So I would encourage you to not look at this right now because it will be relevant for us next week, but it needs to be updated before we do this. Essentially, table joins allow us to take tables where we have, for instance, one data frame with date and another data frame with date and join them together into a single data frame. But we'll see how to do that. We need it for next week's exercise. You don't need it for this week's exercise. And this needs to be updated to show you how to do that before going forward. So are there any questions from you folks? Normally in the course, this is the week where you kind of get like, I don't know what a good metaphor is, like hit with the pandas baseball bat, or like it's a lot of information sprayed with the pandas fire hose. I don't know. It's like a lot of information to take in at once when you start using pandas. And it might take a little bit before things click in your head, but pandas is extremely powerful and useful. And once you start learning how to use it, I was not a pandas guy for years, and once someone finally pushed me to start using it, now I do all my kind of tabular stuff in pandas whenever possible because it's very flexible and it does basically everything you would do, for instance, in Excel. If you want to stick in Python, you can easily do that. But yeah, question? Yeah, so we will cover this also in next week's lesson about how to iterate over, for instance, rows in a pandas data frame. So you can iterate over them and do calculations. You can apply functions to values in pandas data frame. So we'll show how to do that next week. Yeah. But one thing I should show you all before you sneak off for lunch or whatever you're doing next is our exercise for this week. So we have in this week's exercise, like we did I think last week as well, 4 problems. And you can find the exercise as you normally would on the course page. We're going to be working with a data file from the U.S. National Oceanographic and Atmospheric Association, I think is what NOAA stands for. Maybe it's administration, it's the second A. And our data file format looks like this. So it's a little bit different than what we've worked with in today's lesson. We have, instead of year moda, we have year moda hermun, which is year, month, day, hour, and minute. So we have a little bit more precision to the times that we're working with. You can see, for instance, here's 20 minutes difference and 30 minutes difference between when these values are recorded. And we have some other things here about wind speed and other stuff like that in our data file. We also, instead of having just missing data represented by no value between the commas, we have different numbers of these asterisk characters. So you're given some information here about the data file format, as well as I think there is a hint in the exercise about how to deal with reading in this data file, because it is a little bit more complicated than what we've dealt with before. But let's have a look at the problems here to give you a sense of what you will be working with. So our first task is to read in our data file. And so you'll read our data into a variable called data. And here you're given the tip that we haven't used this NA values thing when reading a file with the read CSV function from pandas. But if you give NA values and then this stuff after it, it will find any column that contains these number of asterisk characters and convert them to not a number values, which is what you want to do to be able to read the data file in. So when you do read.csv, you want to include this as a parameter to read in the data file. Once you read it in, you do a little bit of basic exploration. How many rows, how many columns, or what are the names of the columns, what are the data types for the different columns, and Then these temperatures you have that you're working with in this data file, because it's from the US National Oceanographic and Atmospheric Administration, are in Fahrenheit. So you're going to be doing things like finding what's the mean temperature in Fahrenheit, what's the standard deviation of the maximum temperature, and a few other things. Basically stuff from the first part of today's lesson. So problem one is kind of data exploration. Problem number two is kind of more like things we were doing in this second part of the lesson today. So we're going to be selecting data and things like that. So again, we read in our data file like we did before, check that it looks like it was read in properly, and then we're going to select from our data file only these columns. And then we're going to remove all rows from our selection that have no data in the temp column using the drop NA function. After that, you're given a conversion equation here that perhaps looks somewhat familiar about how to convert temperatures in Fahrenheit to temperatures in Celsius. So you're going to then take this and calculate a new column called, I think it's Celsius. And in that column, you can store the values of the converted temperature from Fahrenheit to Celsius. And then you'll convert those Celsius temperatures into integers, as we have seen before. And finally, what you're going to do is select the rows from our data frame with this. This is basically kind of an identification code, one that identifies the station as the Helsinki Kumpula station and another that identifies the Rovaniemi station here. And you're going to split the data frame based on this USAF code number, whether it's the Kumpula or Rovaniemi case. And after that, you'll save your data to a data file. So write it out like we did in the first part of today's lesson. Final problem for this week in terms of things that count for points is our problem number 3 about data analysis. So we continue on here, first by reading in the data file you just produced. So you wrote out these two different data files for Kumpula and Rovaniemi, and we'll check to see everything looks okay. Then calculate what's the mean Celsius temperature for these two locations. Median Celsius temperature, and you can store that in a variable called whatever, median. Then you can select the rows that are from the month of May 2017, store those as May, and you can do the same thing for June, and then you'll be checking the values you have selected here, and then you can make it easier to compare the values between these two locations by printing something out to the screen. And finally, there's a few questions at the end. Problem number 4 is optional. I think problem number 4 was optional last week as well, and the week before. So this one is a bit more challenging. You can find a description of what to do here, but essentially, we want to take these temperatures that are measured at a frequency of something like 20 to 30 minutes apart and aggregate them down to be, I think, daily temperatures. So we might have something like, 70 some temperatures measured for each day, and you want to combine those down to a daily average temperature. And there's not a whole lot here about how to do this. It's just kind of a challenging problem for those who are looking for a little bit of extra challenge. But what you can do here is essentially what's suggested, and we'll actually come back to this idea of data aggregation in next week's lesson, because we'll be talking about how to do this exact same kind of thing, because it's also a fairly typical thing that you want to average values for different period of time than the frequency in which they are recorded. So those are the exercise questions for this week. If you haven't already, I would once again remind you to please fill in the midterm course feedback for those who haven't done so yet. I saw just from the reminder that we gave this morning that there was some, maybe 5 people who had filled it in during the time that we were here. So please fill that in. It's very useful for us to know how things are going in the course and what kind of things we could improve in the future. And are there any questions about the exercise for this week? Okay, if not, I think that's it for today, and we will see you guys back here next week or in the exercise sessions on Thursday and Friday this week.